Welcome everybody to a new session in which we're going to discuss terms that might be vaguely understood, and these are the X-ray dose units and the X-ray dose measurements. By definition, dosimetry is the determination of the dose given to tissue or the quantity of radiation exposure. Of course, each one of these will give something different. We will understand by the upcoming slides. Interaction of radiation with matter results in transfer of energy. What we're measuring in reality is that we must know that a photon, which is the basic component of the X-ray, is a unit of energy that is being given, or the energy is deposited in the tissue, basically on atomic level. Dose is described in terms of energy per absorbed per the unit mass in the site of interest. Of course, depends. Either it's a total body exposure, or in our case, the diagnostic radiology is a predetermined site of interest by the action of the collimator, as you know. Clinically, dosimetry ultimately provides estimates. We don't give accurate numbers of the biological effects of radiation, from which appropriate therapeutic and diagnostic use can be determined. And there are several methods, of course, that are used to measure the quantitative effects of ionizing radiation with matter. So we must understand basically that what we are measuring is energy being deposited into the tissue. When it comes to terms, we are going to deal with 4 terms of X-ray dose units and measurements, or let me say ways of measurement. The first is the exposure, the second is the absorbed dose, third is the equivalent dose, and the last, which we will use always, is the effective dose. Let us understand what these terms mean. Exposure is a measure of radiation quantity. So what we are measuring here is how much radiation. Okay? Or how is this measured? It is measured by the capacity of radiation to ionize air. Now we must understand that a photon, which is the basic component of ionizing radiation, X-ray / gamma, those photons, they have the ability to split atoms, stable atoms in air, to ions. So what we are going to measure here is we are going to measure the amount of ions or ion pairs which are formed when they are struck by a photon. And the unit of measurement is Röntgen. And Röntgen, I will just which is abbreviated as capital R. 1 Röntgen is the amount of X or gamma radiation that can produce certain amount. Don't forget the numbers, because I know that dentists are not that familiar with numbers. So what we must understand is that 1 Röntgen is the amount of X-ray or gamma radiation that can produce ion pairs, certain number, in 1 cc of air at a standard pressure and temperature. 1 Röntgen is also expressed in coulombs per kilogram. So as you can see here, it's an electrical charge in a unit mass here in kilograms. Exposure This is, by the way, Professor Willem Conrad Röntgen, and he's the first Nobel Prize winner for discovering the X-ray. And to him, to this man, we actually owe lots of what we know in radiology these days. Exposure. When ionizing radiation interacts with matter, ions are produced which have net charge, either positive or negative. They are equal by the end. Counting the resulting ions which are formed in air is the simplest method of measuring the quantitative effects of radiation. I again concentrate on the quantitative. So you bring 1 cubic centimeter of air, you strike it by X-ray. If this number of ion pairs current is formed, then you have exposed this 1 cubic centimeter of air to 1 Röntgen. The quantity exposure is a measure of radiation on the ability to produce ionization in air under standard temperature and pressure conditions. It provides a measure of the radiation present in an environment, not in a tissue, and is useful in a survey measurements. So actually what we have here is we have X-ray, ionizing radiation or gamma ray, and then we will have ionization of air. There is no tissue, no biological tissue, no biological effect here. It's the measurement of ionization of air. Thus it measures quantity, not the quality, not the energy given. Gray is the unit of measurement, which is 1 Röntgen is equal to air kerma, that is the kinetic energy released in matter, in the standard international units, and it is expressed in the units of those. So gray, abbreviated as GY, equal as 1 joule per kilogram, replacing the traditional unit of Röntgen. However, still Röntgen is being used, but if you want to refer to the standard international units, then you're going to express the unit of exposure in grays, as we will understand in the upcoming slides. Again, this is the man, as I said, Prof. Röntgen, and in Germany still the X-ray is called Röntgenogram, and the X-ray is called Röntgen ray in honor to this person. The radiation absorbed dose, which was previously abbreviated as RAD. RAD is a measure of the amount, this is the second term, so exposure is measuring the ionization of a known amount of air. The radiation absorbed dose, which is the second one, is a measure of the amount of energy absorbed. Now we're not talking quantity anymore. Now we're talking about quality, because here is energy being deposited into tissue. So this is a measure of the amount of energy which is absorbed from the radiation beam per unit mass of tissue. Here there is no specification of either the beam or the type of tissue. The absorbed dose describes the energy absorbed from any type of ionizing radiation, any type of radiation that can ionize, that can produce ion pairs per unit mass of any tissue and any type of matter. And the unit of measurement in the standard international units is gray, and gray here, as you can see, is measured in joules per kilogram. But if you go to the exposure is measured in coulombs per kilogram. So here it is electrical current, but here it is energy being deposited. The original unit was radiation absorbed dose, which was abbreviated as RAD, and it is measured in ergs per gram. Again, this is before the introduction of the standard international units, and 1 gray is equal to 100 rads. 1 gray which is the radiation absorbed dose, is equal to 100 or 100 rats. And this is Professor Gray, whose name was given to the radiation absorbed dose unit. The third type of expressing or measuring the X-ray is the equivalent dose. Equivalent dose is a measure which allows here, if you concentrate, a measure which allows comparison between different types of radiation. If we go back to the radiation absorbed dose, we cannot specify, or it does not express the type of radiation, neither the type of the tissue. So it's very generic. But if you want to specify the type of radiation, then we're going to talk about the equivalent dose. So this measurement allows the comparison between two different, or between more than one different type of radiation in regard to their absorbed doses in the body, which is known as, now we're talking about a human body or any soft tissue or any biological tissue. Let me be more general. So here it is the radiobiological effectiveness. Now we want to understand the effect of a certain type of radiation on the living tissues. The unit of measurement in the standard international unit is the sievert, abbreviated as SV. Sievert is a big quantity of radiation, so it is subdivided into millisieverts, which is equal to 1,000 of a sievert, or it is subdivided further into microsieverts, and this is the sign. Please look at the millisieverts and the microsieverts. Microsieverts is 1 in over a million of a sievert. And in diagnostic radiology, we're actually toggling between the microsievert or millisievert. We're more towards the microsievert, so we're talking about smaller doses of radiation. Originally, before the introduction of the standard international units, this dose, the equivalent dose, was called the Röntgen equivalent man, and abbreviated as REM, R-E-M. If you want to know the relationship, 1 sievert in the standard international unit is equal to 100 rems. And this is Professor Sievert, to which the unit was given according to his name, the equivalent dose, the sievert. So now we're dealing with 3 measurements: Röntgen, Gray, and sievert. Now let's understand the relationship between those